Then let's talk about our last routing algorithms, which is a hierarchical routing. So so far we already learned two routing algorithms. First one is a link state routing algorithm. The second one is um, distance vector routing algorithm. But both these two routing algorithms, they are based on the idealized scenario, which means the entire network is flat. So what the flat means is all routers, they are identical. There's no difference among the routers. But actually that's not true in reality because in the entire world, there are more than 600 millions of destinations or devices connected with the internet. So it's impossible to store all the destinations in the single routing table, and because the processing time or the delays, you can imagine how long it will take to look through the very long forwarding table. So that's impossible. And also the routing, the routers, they need to exchange the routing informations among the routers. If we insert this much of writers into each forwarding table, you can imagine the entire network will be overloaded only by the exchange the information among the routers. Therefore, we need administrative autonomous autonomous network, which means each network can manage the traffic within its own network. If that's the case, so we don't need to worry about the um, scalability problems. And also we know the internet actually is the network of networks. There are numbers of networks, they are connected with each other to form the internet. Then we have the concept of the hierarchical routings. So the mean of a hierarchical routing is we aggregate the routers into a regions. Actually, these smaller numbers of routers, they can constitute a network. Here the regions actually, each region actually is a network. And for each network, we gave a specific name. We call it a autonomous system. And routers in the same uh, autonomous system, here we short it as AS, run same routing protocols. So that means within the same network, all the routers, they will run the same routing protocols, no matter it's a link state routing protocol or distance vector routing protocol. And also for this routing protocol within the same AS, we call it intra-AS routing protocol. And the routers in different AS, they can run different intra-AS routing protocol. However, since we have numbers of autonomous systems, so and all these autonomous systems, they must connect with each other. Therefore, we needed a way to connect this network together to form networks or to form an internet. Therefore, we have a gateway router. So the function of a gateway router um, is at the edge of its own AS and also has a link to connect routers in another AS to achieve the purpose to connect all the AS together to form a single internet. Then let's see this interconnected ASs. So the forwarding table is configured by both intra-AS and the inter-AS routing algorithms. So actually this forwarding table is calculated by these two routing algorithms. For the intra-AS routing algorithm is to configure how the datagrams can be transferred within an AS. But for the inter-AS routing algorithm, we'll configure the datagram how to transfer between or among the ASs. Here, suppose the router in AS1 receives a datagram destined outside of AS1. Then the router should forward packet to gateway router. However, under this slides, you will see this example. For AS1, there are two gateway routers. One is 1C, which connect with AS3. Another one is 1B, which connect with AS2. So before we transfer the datagram toward its destination, we have to know some informations. The first one is the which destinated, or I mean the destination is connected with which autonomous systems to connect with AS3 or connect with AS2. Another important information is for this reachability information must be propagated to all the routers within AS1. So that means 1A, 1B, 1C, 1D, all of them, they have to know this information. And also for these two informations, to know these two informations, actually, okay, the AS1 can get it from inter-AS routing protocol, because that's the job of an inter-AS routing protocol. Then let's see an example how to set in forwarding table in router 1D. So suppose that AS1 from an inter-AS protocol learn this information that the subnet X is connected with AS3 and also AS1 connect with AS3 through gateway router 1C. And from this inter-AS protocol, AS1 can know this informations. And then the inter-AS protocol will propagate this reachability information to all the internal routers within AS1. And then router 1D will determine how to calculate the least cost path from 1D to 1C, the shortest path, or the least cost path, which is based on the intra-AS routing protocol. And after the calculation, 1D knows that through interface L, which is here, can reach 1C with the least cost path. Then router 1D will insert this information, this tuple, two tuples. The first element is the subnet X. The second element is the interface L on 1D to insert this information into the forwarding table of 1D. However, the real reality is even complicated. So we will make this example more challenge or even complicated or more closer to the reality, which is now suppose AS1 learns from an inter-AS protocol that the subnet X is reachable from AS3 and also from AS2. To configure forwarding table, the router 1D must determine which gateway it should forward the packets towards for destination X. So how to determine which path is the shortest path to destination X? Through AS3 or through AS2? Then the solution is we call it hot potato routing, which sends the packet towards closest of two routers. So let's go back to this to see this example. So suppose 1D from the inter AS protocol know the information that 1D can reach AS3 through gateway router 1C, and the 1D can reach AS2 through gateway router 1B. Then 1D will using or run the intra-AS protocol or routing algorithm to calculate the path cost from 1D to 1C. For example, here is 3, and calculate the path cost from 1D to 1B is 4. Then 1D will choose to deliver the datagram through 1C to AS3, finally reach destination X. So that's the hot potato routing. And then let's do a quick summary for this choosing among multiple ASs. So learn from inter-AS protocol that the subnet X is reachable through multiple gateways. And they use routing information from the intra-AS protocol to determine costs of least cost path to each of the gateways. And then through the hot potato routing, choose the gateway that has the smallest least cost. Finally, determine from a forwarding table the interface L that leads to least cost gateway, and then insert this XL into the forwarding table. And then that's the end of this entire semester. I hope you guys continually being safe and healthy. So we hope we can go through this crazy coronavirus problems and as soon as possible. And also later for next week, I'm going to give two optional assignments. One is a writing assignment. Another one is a programming assignment. So for the third writing assignment, you can use it to replace the second writing assignment if you want to. And also for the third programming assignment, you can use it to replace the um, either programming assignment one or programming assignment two. If you are not satisfied the score you already get from that. And also for our final exam, I plan to give the final exam on the Blackboard through the test test function provided by the Blackboard. And also the questions will be only true or false question and multiple choice question. So for the short answer question and the calculation question, since it's tested on the Blackboard, so I decided to remove it from the final exam. And also I'm still considering if I need to give you guys a comprehensive exam for the final or just to give you guys only the chapter 3 and the chapter 4 on the final exam. I'm not decided yet. So, but I will make the decision as soon as possible. I don't want to give you guys too much burden during this crazy time. So I hope you guys are doing well. It's very nice um, to teach you guys, to learn with you guys this semester, even though we have encountered this really bad situation, but I still enjoy um, the fun part of this semester. Thank you guys.